last lecture we have discussed about ray diagrams, and with the help of that ray diagrams, in today's lecture we are going to do image formation by spherical mirror. In that we will have image formation by concave mirror, image formations by concave mirror. Also, we are going to do image formation by convex mirror, and from that image which is formed by concave mirror and convex mirror, we will be able to give the uses of concave mirror and uses of convex mirror. Okay, so let us start the image formation first by concave mirror. Okay, here we can see that we are having concave mirror. Okay, here first we will have our ray diagram. At different position we are keeping our object. So our second one will be position of an object. As we place our object at different position, then we will get our image at different position. So here we will have another column of position of an image, and the image which is formed, okay, how that image will be in nature and its size. So here we will have nature and size of image. So let's start. In first case, our object is at infinite distance. If our object is at infinite distance, by using the ray diagram, what we can say, that suppose if I take a light ray which is parallel to principal axis and which is coming from infinite distance, okay, according to first ray diagram we know that this light ray which is incident parallel to principal axis will pass from focus F. Okay, similarly if we take the another ray here which is parallel to principal axis, okay, so it will also pass from principal focus F. So all of the parallel rays coming from infinite distance, they are going to pass from principal focus F, and the image which we will get here, okay, we are taking different other parallel rays also, so we can understand it better. So all these parallel rays, okay, they will pass from focus F, they will converge at focus point F, and here we can understand that at this focal point F we will get our image. Okay, so our position of object when object is at infinite distance, so the parallel light rays coming from infinite distance, here they get converged at one point, and that point is our focus. So our image will be on our principal focus. And how that image is, here we can see that the image is very small, and the light ray after reflection they are intersect at one point actually. So our image will be real, it will be inverted, and it is very small, so it will be diminished. Okay, so this is our first case, that if position of object is at infinite, so light rays coming from infinite distance, they will get converge at one point. Okay, so this point is our principal focus. So our image we will get on principal focus, and the image will be real, inverted and diminished. Now let us consider our second case. In second case, we will have our image beyond center of curvature C. Okay, so our position of object is beyond center of curvature C. Okay, so in such case, what is going to happen? Now let us consider, suppose I consider my object here as AB, like this. From infinite distance, if I consider this first ray which is parallel to principal axis, we know that the incident ray which is parallel to principal axis, it will always pass from focus F. So our first ray, it is passed from focus F. Now let us consider the another ray which was passing from F and it was parallel. So I will try to make that ray that which passes from focus F. So according to our second ray diagram, which passes from F, it will always get parallel, and here we are getting intersect. So the object A will form here our image A dash. Same, all of the point between A and B is going to form the image here, which will be A dash, and here we will get a point B dash. Okay, so here we can see that our object was beyond center of curvature, but the image which is formed here due to the reflecting rays, it is between C and F. So where our image will be? It will be between center of curvature C and principal focus F. Okay, and here you can see how the image is. First of all, it is intersecting actually, so our image is real. Also you can see that our image is inverted, so our image is real, inverted, and it is also small, so this will be also diminished. Okay, so this is our second case. So in first case, object is kept at infinite distance, we are getting image on principal focus, it will be real, inverted and diminished. In second case, when our object is beyond center of curvature C, right, by intersecting these two rays which is parallel passing from F, which passes from F, it will be parallel, so we will get our image. Okay, so we will get our image between C and F, means between center of curvature and principal focus F. Image will be real, inverted and diminished. Okay, now consider the third case of concave mirror. In third case, if we place our object on center of curvature, so if our object is on center of curvature C. Okay, so let's see where we are getting our image. So first I will take my object on center of curvature. Okay, so suppose this is my object A B. First ray which is parallel to principal axis, we know that this ray which is parallel to principal axis, it will pass from focus F. So this is our first ray. Okay, the second ray which passes from principal focus will always get parallel. Okay, so which passes from principal focus, that will always get parallel, and we are getting here our image. So here we will have an image A dash, B dash. So here you can see that the image, it is formed on center of curvature. So when the position of object is on center of curvature C, our image will be also on center of curvature C. Okay, here we can say that the reflected ray, it is actually intersecting. So that will be our image, will be our real. Also you can see that AB, it is B dash A dash. So it will be inverted. And the size of the image, it will be same as the size of object. So the image will be real, inverted, and same in size as object. Okay, now consider the fourth case. In fourth case, when our object is kept between C and F, so when our object is between center of curvature C and principal focus F. So now let's see that how we are getting our image. First, if I place my object AB like this, object AB, okay, first ray which will be parallel to principal axis, we know that the light ray which is parallel to principal axis is going to pass from principal focus F. So first ray parallel to principal axis passes from focus F. Now second ray which passes from principal focus, okay, second ray which passes from principal focus, that will be parallel to our principal axis, and here we will get our image A dash, B dash. Okay, here you can see the image which is formed, it is beyond C. Okay, so when the object is placed between C and F, the image we will get, it will be between, it will be beyond center of curvature C. Okay, and how that image is? The reflected ray are actually intersected. So our image will be real. Also, it will be inverted. And here you can see that the image, it is bigger in size. So our image will be magnified. And image will be magnified. Okay, so okay, in fifth number ray diagram we will study when the object is placed on principal focus F, object is our AB. So how image will be formed and where image will be formed. So first, where is our object? Our object is on principal focus F. So when our object is at principal focus F, according to our ray diagram, first which is parallel to principal axis, it passes from F. So here we are going to pass it from F, and second ray which passes from C. Here you can see that when according to the ray diagram, when it passes from C, it will return back in the same direction. Okay, so here we can see that it is not going to get converge at any one point, so we will get our object at we will get our image at infinite distance. So when our object is on principal focus f, we will get our image at infinity. Okay, how our image will be? Our image will be real, it will be inverted, and it will be extremely magnified, means it will be too much bigger. Okay, now in 6th number ray diagram, we are going to understand that when the object is placed between F and pole P. Okay, so when our object is placed between pole P and principal focus F. Okay, so when our object is placed between pole P and principal focus F, so in such case, suppose my object I am placing here as AB. According to our first ray diagram, that which is parallel to principal axis, it always passes from focus F, and the second ray which passes from C, it returns back in the same direction of C. Now as I extend this reflected ray in backward direction, here also this ray in backward direction, I will get here my image as A dash B dash. Okay, so we can see here the image is formed at backside of mirror. So where is our position of image? It is behind the mirror. One more thing, how our image is, here we have seen that the reflected ray, it is extended backward and we are getting the image. So as the it is extended backward and we are getting the image, so our image, it will be not real, it will be virtual. Also we can see here the image is same AB, so image we will get A dash B dash, right? So so our image will be virtual, it will be erect, and here you can see the size is also magnifying, and size is magnified. Okay, so this way we can understand the image formation by concave mirror. Again, just have a quick look on it. In first diagram, from infinite distance we will get on principal focus, it will be real, inverted and small. Okay, then beyond C we will get it between C and F, real, inverted and diminish. In third, when it is on C, we will get the image on C only, real, inverted and same in size. It goes between C and F, right? So we will get it beyond C. When it is on F, we will get it infinite distance. When it is between F and P, we will get it, right? F and P, we will get it behind the mirror. Now these 6 are the image formation for concave mirror. Now we will study about how image is formed in convex mirror. In convex mirror we will have only 2 cases, so let us go for it. Okay, now discuss about image formation in convex mirror, and in convex mirror we will have only 2 cases. In first case, our object will be at infinite distance, and in second case our object will be between infinite between infinity and pole P. Only two cases are there in convex mirror. So let us understand the first case. Suppose if it is at infinite distance, so we know that the light rays which coming from infinite distance, okay, if I take here the two light rays parallel, right, first light ray and this second light ray, we know this is a convex mirror, so it will not converge, it is going to get diverge, the reflected ray, like this. Now according to this, if the light ray is reflected like this, so how we will get the image? Now we have to extend this light rays in backward direction. So as we extend the light ray in backward direction, we will get that image on principal focus F. Okay, so from infinite distance, if the light rays are coming, we will get the image at principal focus F. Okay, so how the image will be? Here we are saying that not actually the reflected ray is intersected, we have produced it backward, so our image will be virtual, it will be erect, and it will be very small, so it will be extremely diminished, means extremely small. In second case, when our object is placed between infinity and pole P, so if the object is between infinite and pole P, suppose here I am taking our object like this, object AB, according to the first rule that the parallel light rays which is incident like this, it's a diverging mirror, so it is going to get reflect back like this. And the second ray, that when it passes from C, we will get it back in the same direction. So when it passes from C, it will get back in the same direction. Now when we extend this light rays backward, so see this parallel light ray, it will pass from F, we know, and this which passes from C, it reflects back in the same direction. As I extend it backward, here there is intersecting of these two rays, so here we will get an image A dash B dash. So where we are getting the image, it is between pole P and principal focus F, so it is between pole P and principal focus F. How the image is, here also we have seen that the light rays is not actually intersecting at one point, we are producing it backward and we are getting the image, so our image will be virtual. Here also we can see the image is erect and the image is small than the object, so it will be diminished. Okay, so this way we can understand the image formation for convex mirror. Now due to this properties of concave mirror and convex mirror, what we understood that concave mirror generally they can give us real image. Okay, the image will be inverted and it can be diminished. In some cases it is same in size and in some cases it is enlarged. But due to convex mirror we are always getting the virtual, erect and diminished image. Due to this properties, there are different uses of this concave mirror and convex mirror. So according to that properties, let us start the uses of concave mirror, where this concave mirror is used. So due to this property of concave mirror, and as it is a converging light, so generally it is used in torches, searchlights, and also it is used in vehicles and headlights. Why? To get a parallel beams of light. Also this concave mirror is used in shaving mirrors to see larger image of the face. This concave mirror, it shows us enlarged image also. So this concave mirror, it is also used by dentist to see teeth of patients. And also this is a converging mirror, it converges light ray at one point. So due to that property, it is used in solar furnace. Okay, and what are uses of convex mirror? So due to its property of virtual, erect and diminished image, this type of convex mirror are generally used in rear view mirrors in vehicles. Why? Because the image will be virtual, erect and diminished, it will be small. So from backside, if any of vehicle is coming, so we can get a small image and the erect image of it in such type of mirror. So it is used as a side glass or the rear view mirror. Okay, second thing, due to this we can use this convex mirror as a security purpose in different type of shops. So it's used as security mirrors. Okay, so this security mirrors, the shop owner can keep on eyes on customer to look for thieves and shoplifters among them. So these are the uses of convex mirror.